So for anyone that's speaking today, apparently this is the sweet spot, all right? For the folks that are joining us virtually, hello. Oh, camera, hello. How many of you were at IZOF Data Summit these last 2 days? Is it everyone? All right, pretty much. So what you're gonna hear next is a use case using not just differential privacy, but OpenDP as a library, as a tool, as a resource. So what was shared at IZOF was kind of an overview. What was the impact? Who did it help? What were the audiences? Today's presentation, they're gonna dig in a little bit deeper. Specifically, how was OpenDP used? What challenges did they face? And hopefully there's some next steps that we could talk about, and obviously wanting some input from the room as well. So please welcome Federico Sanson from the UNHCR and Nitin Kohler from UC Berkeley.
The slides. I'll just be after the side while you start. Good morning, everyone. I'm Federico. I work at UNHCR as data curator. UNHCR is better known as the United Nations Refugee Agency. So I'm here to give you a very quick presentation of what we did, UNHCR with data, with microdata, and the project we did to test and utilize OpenDP to produce synthetic data to be shared with other organizations. So UNHCR collects every year a big amount of data. Most of it is microdata. So we're talking about individuals, households, often put together in more than a data set with many tables that are related to each other, linked to each other. And most of these surveys are sample surveys collected for many different purposes, for operational reasons, so to assess the needs of refugees or to see the effectiveness of some programs that we did, etc. And then we also have a very particular kind of microdata, is registration data, which basically is a census of all refugees around the world for each country. And we keep this big database to reach out to the refugees to provide to them assistance. So the idea is to make these data sets available, both internally and externally. So we prepare this microdata, we make sure that it can be safely shared with third parties. And we do this for many reasons. The first reason is that most of the data is collected for operational reasons, so for specific purposes, but then it wasn't utilized again. So the data collection can be quite expensive, time consuming. Also, there are not many data sets about refugees. It's a very particular niche. But this data can be very useful also for other organizations. You can think about NGOs. They work with refugees. They don't have the budget to do data collection. So sharing with them this kind of data can be very beneficial for them. So 5 years now, we have the UNHCR Macrodata Library online, which is a website. Everybody can go there and browse all the available microdata from UNHCR. They can request the data set, download the data sets, and work to produce research, inform policies, do whatever they want. So we have many end users. They are using our data. We are growing fast. We already have many use cases or data. We have many papers, textbooks that were written and published thanks to our data. So there is big demand for this kind of service. Here we have a quick breakdown of all the available data sets. You can go there, browse by country or by region, and see also the topics. You can see also we have many data sets from other organizations. So often they produce data sets, but they don't have a library to share their data sets. So we can also host data sets of other organizations. Everything about forced displacement. Currently, most of the data sets that are on the UNHCR macrodata library have been anonymized with statistical disclosure control methods. I think most of you are familiar with this methodology, but basically focuses on few variables called key variables, reduces the details, reaches a certain level of anonymity, and then the data set gets shared. Of course, we want to stay on the forefront of the newest technology, and that's why we tested OpenDP, differential privacy, because we saw the benefits of a better technology that guaranteed better privacy. And so we took this new approach. Now, we tested this project. As I said before, we have the census data, registration data. We tested this new approach to differential privacy to create synthetic data of the registration data sets. There are a few reasons for this. The first is that with a census, we have some issues to share with the previous methodology. The main reason is that when you get a census, the estimated risk is very high. So the only way was to reduce a lot of the detail or to share only a small sample. And of course, the utility would be much lower. With OpenDP and with synthetic data, we were able to produce a full-size data set. So this was a big advantage. Then, of course, since census is more sensitive, differential privacy add a better layer of protection. And the other advantage that we saw with the synthetic data was that the workflow was very similar as before. So to produce the data set, to publish on the macrodata library, also for the researchers, which is the most important thing, for them was very similar, the workflow. They can download the data set, work on the synthetic data without any budget limitation. We have a very big base of users with very different backgrounds, so it was important for us to provide a flexible solution. Of course, this came also with some challenges. The main ones were the relational structure of the registration data is quite complex. There are like 10 tables linked to each other. We have a mixed types of variables, and many variables were categoricals. And finally, the dataset can be big with millions of individuals. So on the computation, it could be heavy. So that say, given this quick presentation, I will leave it to Nitin, that work on the data and apply the OpenDP library.
Cool. Thank you, Federico. I'm in the right spot, hopefully, right? Okay. Yeah. Thanks. So after that introduction, I kind of want to give a quick overview of the registration data a little bit more in detail, because it might actually motivate a bit of how our solution works. So as Federico mentioned, there were around 10 tables, and they had a relational structure. So there are, I guess, 3 levels, right? At the root is the registration group. So, and then there are stuff below it. And that key one on the right-hand side is the individual table. And this has a lot of child nodes to it. So an individual table, just I'm going to bounce back and forth between slides. I hope folks are OK with that, is actually the most sensitive table that UNHCR had here. So this is the one where every row in the table corresponds to an individual. And there was a certain amount of information that was collected about them, such as like why they registered, what was their legal status, their age, their gender, relationship to their focal point, so on and so forth, where they came from. So with every individual, they're also associated with the registration group. So a registration group would be like, correct me if I'm wrong, Federico, but we both register with UNHCR at the same time. We would have different individual IDs, but we'd be mapped to the same registration group within UNHCR. And in many ways, as we'll see in a bit, the registration group is actually more or less an aggregation of the individual tables. So we're going to use a lot of post-processing guarantees from the individual table to lift up. Let me actually go to the next one. The children of the individual table typically contain multiple attributes for every individual. And these categories that they contain are typically coarse. So if I actually just go back for a second, sorry. So if we look at, that's a good one, right? Education, for example. We know that these educations are going to be typically just like 0 to 1, like no formal education, 1, 2, 3, all the way up to like 18 plus. Those are pretty nice categories. Languages, we know that people can speak multiple languages, but they typically don't speak too many. So because the children of the individual table are actually contain information that's not as sensitive, we're going to actually do event level privacy here, just because of the context of that. And we're going to see that our epsilons are small, so even when things accumulate, we're likely fine. The last one is the registration group and the assistance and entitlement card tables. So assistance is given out to registration groups, and so are entitlement cards. And this registration group, as I mentioned, table is mostly an amalgam of just the individual table for every registration group. What's the size of it? What's the total number of adult males, adult females, minor females, minor males? The only thing that was missing was willing to return, but we got around that in kind of a sneaky way. So yeah, this is the relational structure of what we had. And if we actually had just like a small number of tables, like let's say maybe 2 or just 3, actually let's just say 2. One idea to create a synthetic data set for 2 synthetic data sets could just be, let me just merge the 2 together, run a synthesizer on it, and then try to split it apart. But we kind of see that the problem is going to be a lot more complex there given the number of tables that we have. So we had to come up with a slightly different approach. Sorry. Right. So here's the intuition of our approach. And I want to state that I've actually chatted with Michael and Salil afterwards on this. So this is just the approach we used. I'm actually really excited to hear other approaches that people have to relational data synthetically, because I know this is not a very easy problem in general. So one thing we decided to do in particular, before I get there, within each table, we needed to actually keep IDs that were in there. So I couldn't, for example, I'm sorry, I'm just jumping around a lot. It's 2 a.m. in California. Right, if we only had to I'm an old man. If we only had to create independent, I want to say independent tables where address didn't have an individual ID column or document didn't have an ID column, this wouldn't be that bad to do. I would just run MST 10 times and just, here we go, right? But there's actually, we need to keep the IDs to be able to go across levels and hopefully up and down levels as well. And I'll kind of spoil the surprise. We found that actually going across levels for the method we do is actually not bad. Jumping up and down causes a bit of problems, but we'll get there. So the intuition of our approach was, let's actually try to keep the ID column that are in some of those child tables as a categorical variable and synthesize with it. Now, I want to point out the ID here is not somebody's name or social security number. It's just an integer that was randomly assigned. So, because you can imagine that if I keep somebody's social security number in there, the presence or absence of them is pretty identifiable then. So one thing, if we look at the skill table here, there's an individual ID, type of skill they have, and whether they have a desire to use it. Are they a carpenter? Are they a mechanic, etc., and so forth. So imagine I ran, let's just say MST, to get a synthetic skill table. Okay, I would get some column that has individual IDs with some skill type and with some desire to use. But one thing we noticed is that because the individual IDs can either show up very few times or a lot, the distribution of counts we get can actually be quite skewed. And we tend to see this in particular whenever we have histograms that have very small numbers. When we add noise, we get lots of very zeros or small occurrences. So to get over this, we thought of something just a little more computational. Our first idea was well, if I know that if I'm likely to get an undercount of counts if I sample, let's say, n rows from the synthetic skill table and there were really n rows to start, what if I sample a bigger table to start? So what if I sample a table that's maybe 3 times as large or 5 times as large? Then I'm more likely to get counts that are close or even overestimate them at times. So one thing I can do then is I can actually, on the individual ID, just create a histogram of how many times the counts show up, measure that in a differential private manner, to then calibrate if I have an overestimate or underestimate there. So I oversample to get more counts, and then what we do is we trim excess records in a differential private manner by looking at the counts of how many times IDs occur. So kind of as a play with subsample and aggregate from Adam Smith, Kobe, and Safia, we call this oversample and trim. we actually purposely get a bigger data set to get more records, and then we trim down excess ones to get the distribution of the individual ID occurrences to better align. Yeah, I'll just kind of skip the next two because it's just kind of a little more pointless details. But the way we did this then is this actually allowed us to use OpenDP kind of as is and just stitch things together very well. So we actually use Microsoft Azure and Databricks because that's what we use at the United Nations. This was implemented with Python and Spark. And yeah, this is how we did it. And I kind of want to just point out a few, there was a few reasons we chose OpenDP, right? It's open source. There's a strong research and development community. So we believe there would be strong resiliency and code, like the existence of the code over time. Hopefully that's still true, just yes. But I want to just kind of note that there were just like some practical things we ran into that I came from like a proving theorems background. So actually implementing technology, I did work as a scientist and engineer before grad school, but this was a whole different level, right? I was like, I have to worry about floating point attacks now. there are so many things that we don't worry about in theory. So one thing I found is that some of the tables we had for some countries were very small. There might have been only 1,000 or 2,000 refugees, but other ones had millions of individuals in them. And for that reason, just plugging this into MST and hoping for the best was going to take a very long time to do. So what we could do is we could actually then end up just using the parallel composition property of DP. If we just slice the data into smaller chunks, run MST in parallel, slap it together, things worked out pretty quickly. And PySpark was pretty cool for that. The second thing we ran into, which we had to overcome, is that some tables have within them like unit-dependent structure. So as a concrete example, for one of the countries we looked at, in their assistance table, there are like many different types of assistance you can get. You can be given currency, in which case the amount you're given is like a dollar or a peso amount. But if you're given a medical kit, the interpretation of those two numbers is very different. If I get 1,000 pesos versus one medical kit, if I do like the synthesization, I might get nonsensical crossing between those. So in order to overcome that, what we did is we actually then ended up slicing some tables based on their unit-dependent structure, synthesizing them differently, and then combining them to make sure that there weren't these like synthetic artifacts we see along the way. Because, for example, if somebody had 10,000 pesos is different than 10,000 medical kits, just like intuitively. And the last thing we did is we actually found out that in order to reduce the number of tables we had to synthesize, if we could actually try to lump some things together into related tables and do them all at once, and then separate them out, it was tended to be better. So a while ago I alluded that the registration table was mostly an aggregate of the individual except for this one column called willing to return, which was at the registration group level, but not the individual level. So what we did there is we actually then, before we synthesized, put that column in the individual table and gave everybody in that group, are they willing to return, that same Boolean value. And then when we generated synthetic data, we just post-processed by taking the mode to then rebuild the registration table after that. These types of things really just helped streamline the process a bit. And let me actually show you kind of just what happened. So there's going to be two baselines we compare to. One is like this theoretical baseline that we would never get to, which is like, how do I compare against the data that Federico and UNHCR would never release, kind of the classic privacy accuracy trade-off. And the second is the more practical. When we compare to what's currently on the microdata library, what do we gain and what's different? So the second one corresponds to more like the current state of the art. So I've had to actually like really change this table from when I put it in because I didn't know if I was allowed to put country names and stuff. So apologies if this looks a little funny. So I'm just gonna kind of explain what's going on here. On the left column, we have different countries and we list the number of individuals we have in them. So for example, in the first row, we have roughly 103,000 individuals. And in some other tables, like the third one, we only have just shy of 1,200. And what we find is actually when we use this method with different epsilons that are all actually, frankly, very small, even for those at the event level, we define what we called like a threshold pass rate. So we looked at a bunch of statistics and said, are they off by more than 5%? If so, we call that a fail. If not, it's a pass. We found even with this method that we have, we were actually able to still have many things that were above a 90% pass rate. And for some of them, we actually got them all to work, and that's just because of the way the categories were. For some countries, right, you can imagine the origin of other refugees is actually quite small, so the accuracy guarantees are a lot easier to have. But for other countries where there's a lot more places where people can come from, for example, the distribution is just harder. And I want to point out something here. We'll notice for the two smallest ones we have here, in the third row and I should have made better slides, whatever row that is with the 2000, we had lower accuracy, and the values we put here when we tested this stuff have higher epsilons. And this is actually one thing we found was just that as we just cranked up the N we had, like we were able to do a lot better just in general. So we found a minor reduction in accuracy compared to the baseline that Federico would never release. The second result, which I think is the more interesting one, is how do we improve over current methods? And one thing we found is, for those who were in the talk yesterday, I'm going to state this again. We often state like there's a privacy utility or privacy accuracy trade-off. But in this case, we actually found there was both an increase in utility and in privacy. So the reason is, for this anonymous country that I won't name here, in order to use statistical disclosure methods, the data had to be really trimmed down a lot. So that means that for some of the columns, you couldn't release many of the categories that were within them. So it presented kind of a more biased view of what the state of refugees were for that country. But with DP, if we look at the far column, we see that we could actually release more legal reasons while people were released. We could release more genders. We could release more marital statuses, and more importantly, we could release in this country 78 more countries of origin than were currently released before. So not only is the data in that case, like I guess, more representative, but also the relative error in those columns actually reduced relative to the baseline that Federico would not release. So we got more categories released and more accurate information at the same time, plus actually now a proof of privacy with differential privacy. So it's a case where, like, I often say, like, the census had the hard job because they had something released before and they changed it and the accuracy got lower. But this is one where it's like the accuracy got better because you were never going to get the real thing to start. So this is one of the really cool use cases of how pets can actually open up more access to things. Yeah, so in conclusion, using this method, we actually got full-size synthetic data sets with strong privacy guarantees, and we were able to get richer data and more accurate data from it. And I know there are a lot of DP folks in the room who probably have a lot more questions, and I'm sure Federico and I are happy to take them in the 3 minutes, 27 seconds we have.
We do have time for some questions, so if anyone has a burning one.
Can you tell us about how you established the epsilon values? And the epsilon values, they are per table, or are they, can you tell us a little bit about the privacy?
Yeah, let me actually jump back to the big, because this also gets to, like, what is the unit? Okay, so for the individual table, the unit of privacy there is per individual. In all the children of it, it's event level privacy. So then, like, for example, if we had an epsilon of 0.125, if there were 8 people, if an individual had 8 languages they spoke, the epsilon would accumulate to 1 then. The registration group, there was no additional privacy loss because it's by post-processing just an amalgam of the individual table. The assistance and entitlement card is interesting because it's like event level for the registration group. So it's kind of a different thing there. And we did some internal testing beforehand on some other data sets, and we found that given the sizes of the data we had, like, we could actually set epsilon pretty small and keep many of the low-dimensional marginals pretty well preserved. Oh, and I forgot to mention this. So Federico and the team at UNHCR did some user scoping before, and it found out that many of the use cases of these were actually, like, relying just on aggregate statistics or things that would just rely on econometric modeling. So low-dimensional marginal preservation seemed pretty aligned, and that's why we then ran with MST also.
Maybe just a question. So you were, like, releasing categories, like countries that people came from, etc.
Mm-hmm.
So that would imply that you were probably doing some sort of, like, I don't know, tail thresholding or something like that to decide whether or not, when there's small values, you release it or not. But you're reporting it in terms of epsilon, not like epsilon delta or something.
Oh, sorry. Yeah, there was actually a delta in here. I just suppressed it for the slides. Yeah. The delta I think is like, I think it's like at the very bottom of one of the tables at the. Sorry, super zooming. I think it's like 10 to the negative 10. I think.
Oh, okay.
Yeah.
Sorry,
So
yeah.
yeah.
Cool.
No, of course. Yeah. Good question.
All right, we do have to move on, but obviously you guys are here for the full day. Please see them at the break, see them at lunch, and we're gonna move on to our pitch anythings. Thank you very much.
Thank you.
Thank you.